All right, today is Tuesday, the 23rd of February. We're going to do two things during this period. First, we're going to go over this little mini game, and it's out there. All the code is out there. I built it into 10 iterations, and it's out on the P drive for the class under the 2/23/2016 folder. I do want you to realize you don't have to do anything with this. You don't have to put it into your website. You don't have to do anything. I just thought we would take a little bit of a break and talk about this. We should be able to get through it in about an hour, all right? I might go right till 11 o'clock because then I want to talk about the homework assignment, or for many of you, the lack of homework assignment, all right? So we'll talk about that and talk about how we're going to try to quote, fix that next week, all right? So, I've got the folder. No, I don't. This is the same one. It was in both classes. So here it is. I'm going to put that over here. And the final product looks like this. So when we get all done, that's what it's going to look like. All right, again, it's the Bernie Sanders Race to the White House game. Bernie's going, Bernie's going, Bernie's going. And he made it. All right. But he can get stopped at any point along the way. Come on, stop him. No. He made it again. There. See, Hillary Clinton has stopped Bernie Sanders. So it's broken up into 10 different components. It even works on a mobile device, because if I hit F12, you may or may not be aware of this, if I hit F12 and I come over here and I choose the thing that's up here, way up here, can you see where the mouse is? That basically is an emulator. So right now I'm running it into a Nexus 7. I can put it on an iPhone 6, etc. And it is set up that it works on there also. All right, there would have to be changes made, as you can see, because it's not set up to work, position-wise. So I'd have to make some changes to it. But it does work the way it is. So what I'm going to do is I'm going to go over the final product is in index.html. But I'm going to go over all 9 of these one at a time. Typically what I did was I did the race part 1, got to a certain point, saved it, and then started on again as race part 2, saved it, etc. All right, so as you can see, part 1, all I did was I drew two rectangles on the screen. That's it. So that's all that's in there. Then for part 2, did some animation. But notice it's only animating in one direction right now. All right? Part 3, it'll start animating in both directions. It almost looks like the old Pong game type of an idea, when stuff's going back and forth, and you can see that. All right. Part 4, now we've got things coming from the y-axis, but they're only falling one time. So when you see that, there they come. And they're falling at different speeds. Part 5, I just changed this. It looks exactly the same, but I brought a forEach loop in so we can talk a little bit about optimization. In part 6, now they're bouncing. All right, so we previously had our X bouncing. Now our Y-axis, the things on our Y-axis are bouncing. Part 7, now we've got a static. This is Bernie right here, but he's not moving yet. So we've got the bouncing things from the y-axis, and we've got our thing on the x-axis, but it's not yet moving. Part 8, he can now move, but there's no collision detection. So notice he can run right into somebody, and you can't tell anyway. All right. Part 9, it's pretty much the finished game, except there's still the rectangles. So if I come through here, you can see stopped, game over. And if I do this, come on. Oh, come on. There we go. Well, if I got to the end, it would say that I got to the end okay, all right? And then part 10 is what you saw. It's the index part. It's the finished product. Again, it is by no means perfect. There's a lot of things that could be changed in it to make it better than it is. But it's at least a start. So taking it from the start, let me also mention there are 2 folders in here. First folder is called Images, and there's Bernie, there's the flag, there's Hillary, and there's the White House. That's all that's in there. They're just simple JPEGs. And the other one, what I reference in each one of these examples are these documents. All right, here's the W3 Schools HTML5 Canvas page. Here's the W3 Schools HTML5 Canvas tutorial. Here's the Mozilla Developer Network, or the MDN Canvas tutorial. Probably the best one is the top one here. The Canvas cheat sheet. All right, it didn't come out as nice as it actually prints when you look at it on screen. Come on. And it doesn't want to come up right now either. But just to show it to you, I don't want to do that one. It's the one right here. So if you actually do want to learn this, if you've got a desire and what you'd like to do, maybe you've got an idea for a game or whatever, this is the, from Cheat Sheet World, the HTML5 Canvas cheat sheet. All right. And I'm asking this question because I'm ignorant of your answer. All right. How many of you have ever heard of this? channel9.msdn.com. Just raise your hand. Anybody ever heard of it? All right. MSDN is the Microsoft Developer Network. All right. And they've got a lot of different stuff on here. They put a lot of stuff on here for free. All right. Virtually everything that's on here is on here for free. They've got stuff that you can learn how to do different things in here. All right. So why am I even taking the time to show you this? 2 reasons. First, and this isn't in the stuff I gave you, but it's what we'll talk about next week, but not right now. So I want to grab first this. This is, make your first Unity 2 Pong game. This is a thing that's on there under Channel 9 MSDN. So why did I even bring it up? Well, you might, first of all, Pong is kind of an antiquated game, but that isn't the point. When you look through here, they tell you how they go through it, and notice what they talk about. How to restart when you come up with collision. Because the collision detection I did is very minimal. But if you have an interest in that, that's something that you might want to take a look at. All right. They also have a lot of different things that are out there. And again, this is another address, so you may or may not have heard about this. Usually I rip on Microsoft. But if you don't know, Microsoft has got a thing out there. If you go out to mva.microsoft.com, it's the Microsoft Virtual Academy. And they've got a lot of these things.
Gabby, why don't you go ahead and introduce yourself?
Okay. So this is about I don't know how long. This has got several lessons in it. It's right there. But it's called JavaScript for Experienced Developers. So if you want to learn more than you think you're getting from here, or even after you graduate or after you leave this class, you can take a look in here. And notice it's getting started with JavaScript, object-oriented programming in JavaScript, web workers, server communications, and JavaScript libraries. I just got a link to this today, so I haven't looked at it at all. I will tell you, I don't know what people think of me one way or the other, but I find this guy to be unbelievably irritating. But he really knows his stuff. His name is Christopher Harrison, but he comes in and he always, good morning, good afternoon, good evening, wherever the heck you are, and he just he gives this goofy laugh. He says the same thing every time, and then he starts laughing. Maybe that's why. Like I said, but he knows his stuff. I've listened to him do a jQuery presentation, and I think it was jQuery and or Bootstrap. All right, and they've got a ton of these things. But if you just go out here, just so you know this, if you just go out to mva.microsoft.com, notice how it's broken up. I'm not gonna open up any of those, but they've got a whole C# tract. Whoops. They've got tracks for HTML5 and CSS. They've got web development, database development. Now, as you'd probably guess, much of it is very Microsoft centric. And like typically when they do anything, just about anything, they'll do it inside of Visual Studio or whatever. But wouldn't you expect that from a mic? You know, this is all done through Microsoft. And these are all tech evangelists. So these are all senior Microsoft engineers that do this stuff. All right. Again, you might not care, but it's just another thing you can look at if you've got an interest. All right. So again, taking this from the top then. This is the first iteration. So this is the race part 1. All right. A couple things that are in here. First of all, when I first started doing this, I broke this up. I put the HTML in one file, I put the CSS in one file, and I put the JavaScript in one file. Then I realized I was going to have 30 files, and it just got too big. So I just put everything together. All right. So even though I've asked you to make your stuff unobtrusive, for this example, I made it obtrusive, just so you know that. So I'm setting up a canvas, and it's just basically going to be 500 by 500, and it's going to have a 1 pixel solid black border on it. Not very much. All right. So you notice that there's the CSS for it, and we actually create the canvas outside of the JavaScript. And then when you get into the JavaScript, there's really not much code in here. There's 1, 2, 3, 4, 5, 6 lines of JavaScript code. But I tried to comment the hell out of it. So hopefully if you have a question, you can go back and take a look at it. All right? When you work with a canvas element, you need a reference to it. And that's what that is. That's using the get element by ID to get a reference to it. Then if you want to draw on it, I've never tried doing any 3D type of thing. So this is all done 2D. So we need another reference. We need a 2D, two-dimensional context object. You don't have to call this canvas. You don't have to call that context. You can call it whatever the heck you want. All right? And then this just sets the color. So this I'm going to draw. Remember what this looks like when you run it. It's got a red and kind of a purplish type of rectangle. So this one basically says I'm going to set the fill style or the color to red. And this draws the rectangle. It's got the X and Y coordinates on it and the height and width or width and height coordinates on it. Okay, so that's what that is. Then we go and we change the color from red to basically that purple and draw it again. All right. So you'll notice my X and Y coordinates change from 5020 to 5100 because otherwise I'd be drawing one right up on top of the other one. All right. But my height and width are the same. And again, that's why when you look at this, it pretty much, they look the same except the colors are different and they're in a different spot on the screen. So again, not very much code in here, but I put a lot of comments in, so hopefully it'll make some sense to you. All right? Any questions on that? Because I'm just going to keep rolling on then. All right, so part 2. Now look what we've added. We've set the rectangle's X and Y coordinates, their height and their width, and their speed. Their speed, basically, if you don't know this already, and I mentioned this to the class yesterday, am I right in assuming that probably everybody in here at one time, you've either done this or you've seen this, you've had a book where you have one of the things where you page through it, and you write a little, like a stick figure on the end and just page through it so it looks like it's moving one direction or the other? That's kind of the animation that's taking place in here, to be honest with you. And then it's basically crude. In other words, we've got our 500 by 500 screen here. And we've got, let's just say it's a red rectangle. So it's right there. And it's all colored in, so it's all nice and red. Then what we're going to end up doing is we're going to say, okay, now you've got that there, and every second, basically, come through here, remove it, redraw it about 2 pixels over. Then remove it, redraw it again, but do it so fast that it's got the illusion of motion. That makes sense? Because that's pretty much what's going on in here. So again, this isn't new. That's the same thing you saw in the last one. Get the reference to the canvas, get the reference to the context. But this update function is going to end up being called, as it says, to update the position on the screen. All right, and it's what I just mentioned to you in there. That's pretty much what's happening. So I'm saying move the x coordinate over 2 pixels, basically. All right, and you'll notice there that's the update function. There's also a draw function, which again removes what was there on the rectangle, sets the color, and redraws it. So what's happening? All right, well, what's happening is, remember how this works? Remember back in the days of the 119 class that you either use JavaScript runner or you use JS bin. Let's say you use that JavaScript runner. You typed everything in. You've got this main, boom, 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 boom. Everything's in there. You type it in, you go to run it, and nothing happens because you never called main. Remember that? All right, I've done that. Maybe you've done that too. So we've got all this stuff in here. We get down to the bottom, and we call move. That's an actual function call right there. So what does move do? Well, move is right here. It calls that update that I just showed you, and it calls that draw that I just showed you. And it's basically in a loop that says this right here, that's recursion. So it's saying as long as I'm requesting that you continue, call move again. So it's going to call this thing several times, all right, per second really, to make it look like it's moving. So again, it's calling update. That's basically going to draw it for the first time on the screen and move it over a little bit. Then it's calling draw, which will actually do the draw part of it. Again, comments up the wazoo here. All right? And if you don't know what the window.request animation frame method does, I took this right from their page. It tells the browser that you wish to perform an animation and requests that the browser call a specified function or functions to update the animation. You should call this method whenever you're ready to update the animation screen, which is what we're doing. So this is in move. I'm in function move, and I'm calling function move. That's recursion, when you've got a function that calls itself. And also notice in here, this line right here, var move equal function, var draw equal function, var update equal function. Every one of those is an anonymous function. They all have function paren paren. So they're all unnamed functions. What we're doing is we're saying, okay, here's a function. Take that function and assign it to that variable. That's exactly what we're doing, because remember, in this language, you are allowed to do that, to basically have anonymous functions and be able to use those like you can assign them to variables. I mentioned in the class yesterday, this is a parallel, but it's not exact, but it's pretty darn close. Maybe you've heard of in Java, not JavaScript, but Java and other languages that support what are called lambdas, Lambda. That's kind of what this is, or a closure, where you've got an unnamed function, which is also known as an anonymous function, that you're basically using as a variable. All right, so you see what we got now in this example. Okay, we're animating in one direction. Well, what's doing that animation? This line right here. So we're saying, okay, with that line right there, then clear the rectangle, set the color, and draw it. Move it over again, clear it, set the color, and draw it. So boom, you just keep going and going and going. And right now it's going until it's off the screen. You can't see it anymore. Technically, you could say that it's still moving. You just can't see it. Any questions on that one? Then in the next part, again, I'm just going to hit the new stuff each time. So you saw all that. You saw all this. All right. But notice, we're going to have to not only worry about X, we're going to have to worry about Y. All right. X is how you're moving from left to right. Y is how you're moving from top to bottom or bottom to top. All right. And I don't know if this makes sense to you. I was explaining this to the class yesterday. Maybe you've seen this before. You'll notice that for the X coordinate, I've got a minimum of 30 right here and a maximum of 450. Even though technically this position, that's 0, 0, right? So this is 0, 500. That should be 500, 500. All right? And that should be what? 500, 0. Does that all make sense? All right? But when you look at this, maybe you've seen this before. Sometimes when you work with games and other things, what we're going to tell it to do is when you get within 30 pixels, don't go any further. All right? In other words, start moving in the other direction. When you get within 50 pixels that way, do the same thing. And maybe you've seen that before, where if you don't put in something like that, it might still work. But sometimes you get to a certain point, maybe you're right here, and it just freezes. It looks like it's trying to go forward and backward at the same time, and it's just sitting there like that. To try to keep that from happening, that's what this is for. And we'll do it later when we bring the y coordinate stuff down also. All right? So then we come into the update function. Now notice the update function is growing. Check to see if the x-coordinate is getting too close to the left border. So if it's less than or equal to 30, just set it to 30. Don't let it get any less than that, and change the speed. Okay? So speed equals minus speed x. So if you're going this way, go this way. All right? There's a lot of different ways that this could be done. And so that's making the check on the left end. And then the next one is making the same check on the right end. All right? But regardless, when you get done, you want to move it over 2 pixels, either to the left or to the right. Okay? And other than that, everything else that's in here, that's all the same. That's all the same. So there's no other changes. Again, purposely set this up incrementally so you could see what was happening on every step of the way. All right? So with this one, again, it's going, it gets, now it's at 450, boom. So it goes in the other direction. Now it's going and it's at 30, boom, it goes in the other direction. And you notice when you look at this, why 450 and 30? I played around with it until I found something that I thought looked pretty good. All right? All right. Part 4. Now we're going to worry about the y coordinates. Well, I started to use 500 all over the place, so I created a couple constants. Remember that in newer browsers, I can put the word const in there. I can do that. But older browsers may or may not recognize the word const. So I put them in there as vars, which means they could technically be changed, but I put them in an upper case because that's usually what's done for constants. All right? So now we're coming in here and we're creating an array. And it's basically, this is an array of objects. So each one of these Hillaries, these are the Hillaries that are going to eventually fall from the sky. Each one of them has an x coordinate, a y coordinate, so that's their start values. It's got an initial speed, and it's got a size, a width and a height. You'll notice that the x coordinate and y coordinate, the y's are all at 100, but the x's keep going up. All right, because we want one of the Hillaries here, then one here, then one here, then one here, type of an idea. You'll notice that the speed changes. It's 1, 2, 3, and then it's all the way up to 7, which will make it go a lot faster. All right? And you'll also notice that they're all the same size. They're all 40 by 40 because, again, eventually they're all going to hold wherever it was. That. These are all 40 by 40. Now when you start to go through this, now this is the y. This is the y position. So this is the stuff falling from the sky. So these are for loops. I may have mentioned this the other day. I may not have. Please get used to doing stuff like this. This program would have worked just fine if I would have left this line off, right here. If I had left this line off and I would have said here, for var LCV equals 0, LCV less than Hillary's dot length. That would have worked just fine. Why did I do it like this? Somebody who's not Luke, because you heard me say it yesterday. Answer the question. It's somebody not named Mike. Why would you do that? Yes.
It's faster?
It's faster because you're only doing the calculation once. Imagine you had thousands of these Hillaries. All right? Then you'd have to be checking the length every time. But now we're setting it once and we're just using it. It is, for lack of better words, it's a constant. All right? So this is saying basically update the y coordinates and the speed of it. So have it be falling. So again, what this dot speed y will mean is for the first Hillary, have it go down a pixel, the second one 2 pixels, the third 3 pixels, and the fourth 7 pixels. So if I wanted to jack with this to make them work go faster, slower, etc., those would be the numbers I'd be changing. All right? Other than that, when we draw it, we also have to spend a little bit more time because we're drawing. So this is filling an array, and this is drawing from an array. All right? Other than that, it's the same program that you've seen. There's no other changes. And really in part 5, which is the next part, I only changed one part of this, okay? And that's right here. This was a for loop before, and I changed it to a forEach for the same reason that Robert just mentioned, for optimization, to try to make it run faster. Typically, using a forEach will result in your code running faster than a straight for loop. And a for will typically be faster than a while loop. All right, so when you start thinking about, maybe not with this example, but with other examples, when you're coding and you start thinking, well, geez, how can I make this thing go faster? All right, that's one thing to think about. All right, other than that, it's the same program as the last one. Then part 6. Now we want to make them bounce because they're falling from the sky, but they aren't bouncing. All right? So what do? The same kind of thing. Here, just to show you another way of doing it, I didn't make constants. I used 25 as a value there. So when you're within 25, reset it to 25, and here's another way that you can do that. Set the speed equal to -1. So in other words, if you're going vertically down, move it to vertically up, and vice versa. All right? Again, there are plenty of different ways that this could be done. And I started playing with this, and notice too, we used in here, game height -40. So actually using those constants that we set up on the top here, just to figure out, well, when should I have that bounce actually take place? And you could change that any way you wanted to change it. All right? The draw function hasn't changed. The move and the draw, none of these have changed. All right? All right. Now we add another object in here. That's a Bernic object. And notice this Bernic object that we're adding, it's not an array because there's only one of them. All right? There were 4 Hillarys, but there's only one Bernic. This is Hillary's start position, 10,160. This is her speed, 2.5, or his speed, I should say. This is moving. We'll use that later on because if we have the mouse down, we want is moving to be equal to true, and if we want mouse up, we want is moving to be equal to false. That makes sense? All right. But this is just part 7, so I don't think he's moving yet. I don't think is moving on here is ever set to true in this particular example. All right. So again, if he's moving, what's that saying? Move him along the x coordinate. That's exactly what we're saying right here. Other than that, there's nothing new in here. Everything else is the same. So if we run this one, I think this is the one with static Bernic. Yeah, he's not doing anything. So I can click there all I want. Nothing's going to happen. Now we actually have a move, but as it says in here, no accounting for collisions. Remember, this is the one, so there's 2 or 3 more of these to go, but this is the one I can just have them go right through people. And there's not any errors. All right? Does all that make sense? So if we look at what's in here, and we look at what's changed in here, now the is moving has got to be set to true if we want Bernic to keep moving, and false if we don't want him to move anymore. All right, we'll talk about this in just a second, but just so you see it again, in this example, all right, when we start it up again, all right, he is moving, but we're not doing anything with collision detection yet. So we had to do this. This is registering an event listener. So this is saying whenever the mouse is down, call the move Bernie function. Whenever the mouse comes up, call the stop Bernie function. So when it's down, you're calling move Bernie, and remember, move Bernie says to move him. Stop Bernie basically just says don't move him. All right? So you'll notice that when we start running this, now he's moving, but as soon as I let go, he stops. As soon as I let go. So the only thing we have to account for yet is collision detection. And there's many ways that you can account for collision detection. All right, I kind of used in a more simple way, whoops, just so you see it. And again, with this one, I did reference it in here. So it's down near the bottom. There is a collision detection function in here. We'll talk about it in just a second. It's way down at the bottom. But this is what I went out to right here. So I went out to MDN, the Mozilla Developer Network, found this thing on 2D collision detection. All right, again, because with this one, what we want to make sure happens is we want it to stop. So the game is almost done. But when we run this now, there he stopped. And what this is doing basically is look at it this way. What we're saying is the key ingredient right here is that rectangle. And what we're saying is take a look at its coordinates, and if any part of their coordinates are overlapping with any one of those rectangles, the game's over because you've been hit, whatever you want to say. On the other hand, if you make it all the way through to the yellow rectangle and you haven't collided, then you know you've won. Does that make sense? Because that's all that's in here as far as code. That's the only change that was put in here for the code. So when we look, I go back up to the top besides the actual collision detection. All right, so if we look in here, we go up to the top, all right, we have to check for a collision. All right, if we get to the end, Bernie has secured the White House. The game is over. So our thing to tell the game to keep going, we set it to false because we're done with the game. This window.location, you may or may not have noticed this, but when you're playing this, whether I make it through here or whether I don't make it through here, as soon as I click OK, it resets. And that's what the window.location is doing right there. All right, try to get to the end and show you exactly what's happening with it. There. All right, secured the White House, boom, everything resets. All right, and again, the way that that's done inside of here with a collision detection is really simplistic. All right, and it's what I just explained to you. All right, so let's look at the last one and then we're done with this. All right, so let's just look quickly at the last example. And that's the index. So this is the final one. I changed some names. I changed the size of it just so it would work a little more optimally. So I changed it in here. And if you notice, I've got this stuff. That allows it to be, that's what we'd want to turn on or turn off if we had it on a mobile device. All right. And what's weird is I found out by putting in just the HTML comments, not these other comments, but just the HTML ones, when I ran it, those things still ran. So I had to actually embed comments within comments here. Remember what the user scalable equal no does? That says you can't pinch, or pinch to zoom type of an idea. We're just setting it at a size. Some other stuff that you'd want to do if you were doing it for a mobile device, you'd probably want to turn off padding. You'd probably want to turn off margin. You'd probably want to change the background color. You'd also probably want to get rid of the H1 tag right here because you really don't need it. Oh, that's it. You don't need this tag because you've got a limited amount of room on a phone anyway. All right? So then we put everything, we're saying, hey, as soon as you start up, call this load event. Call that function that's called load. And everything, what's load? That's everything that's in the program. That's everything that you've seen. There's nothing else new in here other than we create this object called sprites, and that loads all of the images in. All right, and I skipped over this before. This is registering a mouse down event. This is registering a mouse up event, but this right here, the touch start and the touch end, those are both being set up for a mobile device. Because if you don't set those up and you go and try to play it in a mobile emulator, you'll have no control over it. All right? But other than that, it's the same game. The only thing that we did change a little bit on the end here, where is it? All right. I changed a couple of the names around. All right. But you'll see that we're done now. All right. We just put a whatever on it. She's probably moving too fast right there. That's the one that's 7. So maybe I should have cut that one down, but it added something to the game. So how could you change this? You could set it up so that if you get to the end, you could have another level come up. All right? And maybe every time another level comes up, you add another Hillary. Or you make each Hillary go 1 pixel faster. Or whatever you want to do. All right? So there's a lot of ways that this could be improved upon. But I thought this would give us an idea to really show some of the stuff that was in these chapters. So please take a look at it, okay? All right. The other thing, several people in this room either didn't turn in an assignment for the first assignment, or whatever you turned in for the first assignment was incomplete. All right. So what I'm going to do next week, and I've already started this, and there's one more file I'm going to have to throw in there, so don't grab this yet. But when we start up next Monday, I'm going to have Thursday is going to be a lab, all right? Because I've also started grading some of the other stuff, and a lot of people just have empty folders out there for virtually all their classes. So next week, what I'm going to do with you is literally we're going to build this first assignment as a class, all right? I'm not going to save anything where I'm going to make it available, but if you want to build it along with me, you can. Then you'll have to add your own stuff to it, whatever that stuff is. All right? So if you do that, you turn in within a week, you'll still get most of the points. You won't get all 25. That's not fair to the people who turned it in on time. All right? I don't know exactly what you'll be able to get, but it'll be something and it'll be passing. I don't want to keep doing this every time, but I want us to get to this point. So that'll probably take all next week. Then the following week, we're going to go over chapters 12 to 16, which are basically jQuery specific. And then we're going to go over I think it's 12 to 15. Then we're going to go over 16 to 19, which again is basically jQuery specific. Then you're going to have your next assignment. You're going to have to put a slideshow in there that you're going to run from the front page. You're going to have to put some animation in there and some other stuff. All right, I'll have to look at that. I haven't written it yet. All right, so we will do that. And you'll have probably 1 or 2 weeks of lab to do that. That'll be after the break. All right? And then we're going to go over the rest of the stuff that's in the book, chapters 20 through 29. You will at least be exposed to Angular. All right? How much of an exposure? As much as I can give you. I still want to give you the last 4 or 5 weeks to just work on your projects. All right? Questions on anything I've gone over? Luke had a question, but any questions on any of this stuff? Go ahead.
Now, I was looking in the index that you had, and I was reading on the step. Is that basically the equivalent to the set interval, or are they? And then also, I don't want to get too far ahead of myself, but I'm looking at that collision one, the example, and I noticed in yours there was a math.abs and math like that. What exactly is that?
That what the ABS does is it's the absolute value, because it doesn't matter which direction you're going in. And the max goes and looks at a bunch of values that you have, and it determines which one's the biggest.
Okay.
There's a math.min also. All right, and as far as your question about the interval, it's not identical. No, this thing is basically you're putting that into what's called an FSM, a finite state machine, where we're kind of putting it into an infinite loop, because technically, if you really, really when you think about it, this would be stupid, but technically I could come in here, if I never moved him, I could just stay right here forever, right? And this thing really is moving. I'm not moving on the x-axis. I could also do something like this, where I just went right there, and I could stay there forever. I could do that. It'd be stupid to do it, but I could. So really what we're doing right here is it's not a set interval. It's by calling move several times per second to have it erase it, redraw it, move it, erase it, redraw it, move it, etc. Or I should say erase it, move it, redraw it type of an idea. Because that's what we're doing. You could probably implement it through a thing with timeouts. I think it would be more, I think there's other applications that would be better suited for that than this. All right. Any other questions? So the rest of the period is lab. Thursday will be lab for you to hopefully try to catch up in this class or any other class. The rack is open over there, so if you need a Mac, if you need a tablet or whatever, all right, you can get that. I have sent Adrian an email and an e-ticket request. I said, I can't right now, I can't run using either Eclipse or Android Studio. I can't run in an emulator. I can't. It says that I have no room on my device, and that's not true. So he said to send it to him. So what I did was I taped myself doing everything and literally produced it, threw it out there on YouTube, and gave him the link to it. So hopefully he's going to look at that today. But if you're having problems like I am in here, it really and truly shouldn't matter if you're using Android Studio or if you're using Eclipse. But again, the tablets are right there if you need them. All right. I am going to lecture probably for the first hour today in Android. The second hour will be lab, and we're going to build like about 3 apps today. They're fairly simple, but we're going to build 3 apps in the iOS class. All right. Any questions?